Oh, la, la.
Let's start with the answer.
Good evening, everyone. My name is Anmol Karki, and I would like to welcome you to our mini project presentation on MRTC. Before we dive into the details of MRTC, let me give you a brief overview of our team and our project. Our team consists of Vikrant Shrestha, Isan Panta, Priyanshu Sharma, and Parivartan Timalsina, and we are currently pursuing Bachelors of Computer Engineering at Kathmandu University. Our project is about MRTC, which is an open source tool used for monitoring and measuring the traffic load on network links. As you may already know, network traffic refers to the amount of data that is transmitted and received by network devices such as routers, switches, and servers. It is important to monitor network traffic because it helps network administrators to identify and troubleshoot network issues, optimize network performance, and plan for future capacity needs. This is where MRTC comes in. MRTC is a popular tool that uses the SNMP protocol to collect and graph traffic data from network devices. SNMP is a protocol used to manage and monitor network devices, and it allows MRTC to collect data such as network bandwidth utilization, CPU and memory usage, and other network statistics. In our presentation today, we will be covering several aspects of MRTC, starting with an introduction to MRTC itself, followed by an explanation of SNMP and how it works with MRTC. We will also discuss MIBs, which are databases used by SNMP to store information about network devices. We will then move on to the features and design implementations of MRTC, including the software specification and how MRTC collects data. We will also discuss the setup process and how to configure MRTC for your network. Finally, we will wrap up our presentation with a discussion of the limitations of MRTG and future enhancements that could be made to improve its functionality. So without further ado, let's get started with our presentation. Thank you for listening, and we hope you find our presentation informative and engaging. So about SNMP. SNMP is a protocol used by MRTG to collect and monitor network data. As you can see in the picture, it is used to manage and monitor different network devices such as routers, desktop PCs, laptops, and printers. The SNMP manager sends command to the SNMP agents to retrieve information about network performance and its status. The agents store this information in MIBs, which are organized hierarchically and can be accessed using unique identifiers. In our next slide, we will discuss MIBs in more detail and show you how they are used by SNMP to store information about network devices. Now I would like to call Priyanshu Sharma to discuss about MIBs in more detail.
Thank you, Anmol. Now let's start talking about Management Information Basis, which is MIBS. So MIBS is a helpful communication tool, specifically a database of SNMP, which allows devices to talk to each other. Like Anmol mentioned previously, in SNMP, we have multiple devices called agents, and there are also several managers, conceptually called master. And communication takes place to and from manager and agents. But whenever a new device or new agent is added to this environment, the manager does not know how to work with it. Therefore, this is where MIB file comes into play. It is a text file that contains instruction to resolve all the questions about what the device can do. MIB file is compiled to manager, and then the new agent and manager can talk to each other. Now, since we have an idea about what management information basis is, let's move on to the related works. So in the related works, we have SolarWind Network Performance Monitor. So it is a project that is used to monitor and manage growing network. It is a complete monitoring solution built for network engineers by the network engineers themselves. Like whoever makes our hardware, NPM can make it easy to reduce outages and help quickly detect, diagnose, and resolves the performance issues. Now let's move on to the features of MRTZ. So the features of MRTZs are to monitor graphs on specified time intervals, to create customizable graphs, and to get informations about the incoming and outgoing bits. Now I'd like to call Bikras to explain about design and implementation. Thank you.
So now let's get started on how to set up MRTG on your device. So in order to run MRTG on your device, you'll first need to install a couple of libraries. First, make sure that you have a C compiler available on your device. You need this compiler in order to run the source code of MRTG as it is written in C. The next in your checklist is Perl. Perl is a high-level general purpose language that is widely used in network programming, system administration, and other tasks. So MRTG uses script written in Perl to gather data from network devices, and this generates the web pages that display the gaps. MRTG also uses Perl to perform other functions such as data logging, data analysis, and error handling. Now you need a library called ZD to generate charts. In order to use ZD, MRTG needs to be compiled with the appropriate ZD library. Although most Linux systems have a common ZD library libzd installed, make sure to install it if you don't have it already installed. Next, you'll need libpng that is used to read and write PNG image files, along with zlib that is used to compress and decompress the image data. Finally, you need to install and configure SNMP on your device. MRTG uses SNMP to gather traffic data from the network. Now you will need to install MRTG on your device. You'll now need to create a configuration file that will define which network device or server to monitor, which network interface or resource to monitor, and how to display the results. You can use CFG Maker to create a configuration file for your MRTG. So shown in the slide is a common command used to create a MRTG file using CFG Maker. The first line of the command specifies the home directory or the working directory, that is where to store the data files and the HTML output files. The next line specifies the options to display, whether to display data in bits, bytes, or the growth of data from right to left or left to right, or the interval in which the data is to be collected. And finally, the output line specifies the location of the MRTG file. And finally, the last line specifies the SNMP common string and hostname or IP address of the device being monitored. Now I would like to call Parivartan to clarify more on how MRTG uses SNMP to collect data and create graph files. Thank you.
Okay, thank you, Vikraj. Now I would like to tell about how MRTG collects the data and how we get the graphs in the MRTG. So at first, as Vikraj told, we should install all the dependencies that we need for getting the graphs, and after that, what happens is at first MRTG collects the data from the devices in which the SNMP is enabled. It means that all the devices that we want to monitor should have the SNMP enabled in them, and if the SNMP is not enabled in them, then we cannot get the data because we cannot request them to for the data. And similarly, the we have two devices called SNMP manager and SNMP agent, and the SNMP manager is the one which generates the graphs by using the MRTG, and SNMP agent are those which sends the request to the SNMP manager to generate the graph. So at first what happens is when the SNMP manager sends the request to the SNMP agent, the SNMP agent approves that request, and then it looks for the and it looks if that is legit or not. And after that, it when it approves the request, then it sends the data in the raw encapsulated form from this device, from its devices, to the another SNMP manager device. And it is the data is at first the data is stored in the MIB, as Priyanshu told earlier, and then the data is sent to the SNMP manager. And after that, the MRTG gets this data in the encapsulated form, and the MRTG creates a log file for this graph. And after that, the graphs are created on the basis of the log files and displayed in the SNMP manager. And we can also configure in which interval we want to get the data. Like we can get the data in every 5 minutes, and every 5 minutes, every 2 minutes, every 10 minutes, and we can configure it as we like. Similarly, now talking about the software specifications of this MRTG. As Bikras told earlier, we need all such dependencies, and the main software that we need in this project is MRTG, SNMP, and POL. As we already knew that MRTG is the one which creates the graphs and which creates the graphs of the data. SNMP is the protocol that is used by all the devices to which want to configure the data, and POL is the language. POL is simply a language that is used by MRTG to create the data. So we can get easily available in the internet about the POL, and we can easily install that POL in our devices. And when we have all these dependencies and all this software in our device, we can easily create a graphs. And similarly, at the bottom, we can also get about the incoming bits and outgoing bits of the graph. And for the hardware specifications, so our normal PC with Windows or Linux or Unix can run the MRTG. And it also depends on how many devices we want to monitor the graphs of. Say, like if we want to monitor the graphs of many devices, then we should use advanced computers, because we should store a large amount of files in there, and long data will be there of the files. So we cannot store in the simple computer that we use in our daily life. But if we want to monitor the graph of only few devices, then we can easily use our own devices and monitor its graph and use this system. Now, saying this much, I would like to call Isan for further description.
Thank you, Parivartan, for your part. Now let's talk about the discussion section of our project. In this section, we will talk about the things we are able to achieve through our project. We were able to create a visual representation of the incoming bits and the outgoing bits, which helped us to know the network performance of our device. Also, we were able to understand the different types of MRTG configurations and gain knowledge about the SNMP protocol. We realized how monitoring graphs and monitoring network graphs help us to analyze the load that is going through those networks and to systematically plan accordingly in the future. Now, there were some limitations while we were doing this project. Some of them are we couldn't configure our MRTG in more than one device. We only were able to configure MRTG in our laptop. We wanted to do it in a router, but we were not able to do so. Also, we weren't able to obtain real-time monitoring of data. All of the data that was obtained was in a 5-minute interval or a 30-minute interval or a 1-day interval. There was no real-time monitoring of data. We were not able to do that. Also, we were not able to create a alerting system when a huge amount of traffic passed through the device. A main advantage of MRTG is for alerting when high traffic comes to the device. So that was one of our limitations where we couldn't create such a system. So such limitations can be solved through our future enhancements and our future efforts. In our future enhancements, we have included configuration of MRTG on many devices, not only on our laptop, but also on devices like routers and other devices, making one device the server and the other device the client. So monitoring of both incoming and outgoing traffic. As I said previously, configuring MRTG in router, we were only able to do it on our laptop. So we plan on configuring it in the router as well. Also, we plan on adding an alerting system in the future, which will help us to monitor if there is a high amount of network that is going through the device or the router, which will ultimately help us to plan effectively. So we are able to learn a lot of things from this project, how monitoring the network of a device can help in analyzing different kinds of graphs. We were able to learn a lot of terminologies related to networking and even network graphs. We were able to learn a lot of things. Thank you everyone for your part in this project. It was a wonderful project. Saying that, I'd like to hand over the stage to Parivartan for the live demo.
Okay, thank you, Isan. Now I would like to show you the demo on how our project works. Here in this project, we have used Ubuntu as our working process, and you can see at first what happens is where we in the terminal at first we install all the dependencies and the softwares that we have mentioned earlier. Then after that for making the CFG file, for making at first we need to have one CFG file in our project. So for making the graph, so at first in the as Bikras mentioned earlier, we use we use this command like CFG maker global, and we give the working directory of the project. It means that where our MRTG is installed, and after that and we specify the output where our output will be stored. Like in for this project we have stored the output in the etc mrtg, and there's the mrtg.cfg file. And then we will as we are monitoring the graph of this local device, we are using such public @local host for, and it means that the device which we want to monitor the graph, and it is of this device, so we are using the local host. And when we use this command, we will get the information as mentioned here, like public local host, like this index and all the admin status. mrtg.cfg file will be created, and all these informations will be written in the mrtg.cfg file, like the the target device we are monitoring, and all the devices that we want to monitor. And it is stored in cfg format. And after that what happens is after typing the command, we will use the command given here, env lang equals to c. It means that we are using the c language, because we are using the gcc compiler for this. And then we are compiling this mrtg.cfg file to generate the graph. And after we do this, we will get the graph as shown here. At first I will show you the graph that we did in the that we did in the 20th April. And it shows like the graph is the about the beats per second. It means that the y-axis is showing about the beats, and the x-axis about the time. And we can see here the incoming beats and outgoing beats. Like the incoming beat is 5656 beats per second beats, and then outgoing beats is 5800. And at the rightmost part we can see the green color, that means the incoming beats. And then and the at the bottom part we can see the blue color, that is the outgoing bit. And in this way we can generate the graph after the 5-minute average. Similar, we can generate the graphs of 30-minute as well, 2 hour as well, 2 hour as well. And then this was the graph of April 20th. Similarly, we have generated many graphs. Like this is the graph that I did today, like in the 6th May. And then the graph with the year, what I did was, at first I edited the log file, because we were not getting a good graph about the incoming bits. So I edited the log file. Like in the terminal, we can go into this one of the log files, and then we can edit the log files. Then I edited that log file, and we generated the graph here. And similarly, we can get the graph of the 30-minute, 2 hours as well. So in this way we generated the graph. And in the mrtg.cfg file, we can edit some features, like in how many minutes we can get the graph and all. I will show you that by typing the command. Look here is what when we add this command run as daemon, yes, then the graph will be updated in every 5-minute interval. And then we have since we are doing monitoring the graph of only this device, we have commented all the codes. And then only we have monitor the graph of this device only. Like this is our target device, and we are setting the environment for this, like your set environment. And we are configuring this file. And then we are getting the graph of this device. Like this is the IP, and then this is the if name. This is what the log file contains, and all the data of the log files we are getting here. So we can also view the log files of how our log file is, and we can do that by going to this log file. I will show you this as well. This is the log file what we get here. It is the first column gives description about the milliseconds, that the time, and this second, third, fourth column give information about the incoming bits, outgoing bits. As I am not using this Ubuntu operating system now, so we are getting this zero, because I am not using this Ubuntu now. And then and this so the graph also we are not getting a proper graph here. And then for getting this green graph in the in our file, I edited this log file and checked if our graph was working properly, and it gave a positive response. So I also generated this graph and said we can generate a lot of graphs here. In this way we did our project. Saying this much, I would like to end this presentation, and this was our demo for the project. Thank you.